High in the Bolivian Andes, at nearly 13,000 feet above sea level, sits a pile of broken stone that has quietly humbled engineers for a century. It's called Puma Punku, and its most famous pieces are strange, H-shaped blocks of gray andesite, cut with corners so sharp and joints so tight that generations of visitors have sworn a blade couldn't slide between them. For years, that was just a story people told. But now it isn't just a story anymore. Teams of researchers have pointed lasers, drones, and industrial scanners at every fragment of this shattered platform, building a digital twin of the site accurate to a fraction of a millimeter. And what that data is showing is not a myth, and it's not magic. It's something arguably more impressive, a level of planning, measurement, and repeatable engineering that nobody expected from a culture working with stone hammers and soft metal chisels. This is the real story of what the scans found. Puma Punku sits just west of Lake Titicaca, tied by geography and history to the much larger ceremonial city of Tiwanaku. The name comes from Aymara, the language still spoken by communities around the lake today, and it roughly translates to Gate of the Puma. For centuries, this was a place of ritual and gathering, part of a civilization that, at its peak, influenced trade and religion across a huge stretch of the southern Andes. Radiocarbon dating from organic material buried in the platform's fill, things like charcoal, bone fragments, and plant matter, places the first major construction phase at Puma Punku somewhere between roughly AD 536 and 600. That range comes from statistical modeling of dozens of samples collected over decades of excavation, not a single lucky find. And as more Tiwanaku area radiocarbon data has been compiled and reanalyzed in recent years, that window has only gotten tighter. So we're not guessing at a vague ancient date. We have a fairly confident timeline, and it places the platform's construction well within the world of Tiwanaku's early monumental building boom, alongside temples, staircases, and other stonework across the site. What makes Puma Punku different from its neighbors is the condition it's in. Most of what's visible today isn't a temple. It's a wreck. In the late 19th century, as railway lines were being pushed across Bolivia, laborers used the ruins as a convenient stone quarry. Blocks were dynamited, split, and hauled off to serve as ballast and building material for train tracks. Contemporary accounts from that period describe scenes of real destruction. Carved stones cracked apart by blasting, tightly fitted joints pried open for scrap, and platform sections torn from whatever order they'd originally been built in. Of the roughly 150 documented blocks that made up the H-block architecture, not a single one remains in its original position today. That's the tragic part of this story that often gets skipped over in the more sensational retellings. The mystery of Puma Punku isn't just about how it was built. It's also about a monument that was actively destroyed within living memory, long after it had already survived 1,000 years of earthquakes. That destruction is exactly why the new scanning work matters so much. If the blocks are scattered like pieces of a puzzle with no box lid to check against, then digital reconstruction is one of the only ways left to see what the original design logic actually was. The first major attempt at solving that puzzle came from a University of California, Berkeley team led by archaeologist Alexei Vranic, published in the journal Heritage Science back in 2018. His team combined more than a century of field measurements, some dating back to 19th century explorers, with new laser scans of the surviving stones. They used that data to 3D print more than 150 scale models of the andesite blocks and sandstone slabs, then physically reassembled the monument on a tabletop, piece by piece, almost like solving a stone jigsaw puzzle at a fraction of real size. Early attempts failed. Blocks refused to align, and the platform's signature stepped, T-shaped outline seemed impossible to recover using outdated site maps. It was only after correcting the orientation of several misidentified blocks that the pieces finally clicked into place, and the logic of the original structure reappeared. That project already told us something important. The joints were designed to interlock in 3 dimensions, not just sit stacked on top of each other, but it was a physical model built from historical measurements, not a live digital scan of the stones as they exist today. The next leap came from a very different kind of team, one based at Ball State University's Institute for Digital Intermedia Arts, known as IDIA Lab, working under director John Philwalk. over a multi-year campaign that intensified through 2024 and into 2025. This group deployed drone-based photogrammetry, essentially stitching together thousands of overlapping photographs into a three-dimensional model, along with ground-based laser scanning, to capture the site in extraordinary detail. The resulting digital twin lets researchers rotate, measure, and digitally reassemble the ruins on a computer screen, testing hypotheses about the original layout that would be physically impossible, or at least wildly impractical, to test with the real 100-ton stones sitting out in a Bolivian field. So what did all of this scanning actually confirm about how the H-blocks were made? The first thing worth understanding is the material itself. Petrographic analysis, essentially thin slicing the stone and studying it under a microscope, confirms these blocks are cut from andesite, a hard volcanic rock, and that this stone was sourced from quarry sites located a real, measurable distance from Puma Punku itself. In other words, this wasn't some artificial material poured on-site from a mysterious recipe. It was ordinary volcanic rock, quarried the way ordinary volcanic rock gets quarried, then transported, likely using a combination of human labor, ramps, and possibly llama-assisted logistics, across the Altiplano to the building site. That transport alone, moving multi-ton blocks of stone across high-altitude terrain without wheels or draft animals capable of pulling that kind of weight, is already an engineering feat worth respecting on its own terms. The next question scanning helps answer is how the surfaces got so smooth and the corners so sharp. Detailed surface and toolmark analysis on the andesite blocks reveals something specific. Not clean, single decisive cuts, but repetitive abrasion patterns. That's a technical way of saying the stone shows the marks of being worked over and over again with basic tools. Most likely stone hammers for rough shaping, followed by harder abrasive stones, and possibly bronze or copper chisels for finer work, gradually wearing the surface down to the desired shape rather than slicing it in one motion. This lines up with what we already know about Princa-Andean metallurgy and toolkits from other Tiwanaku-era sites. Additional surface studies suggest the builders may have used a slurry, essentially a wet, gritty paste, as a kind of natural polishing compound to smooth interior angles and get that glass-like finish on the tightest joints. If that holds up, it offers a fairly mundane and frankly elegant explanation for surfaces that look almost machined, patient, repetitive grinding, not some kind of exotic casting process. Now, the tolerances themselves are genuinely remarkable. And it's worth being precise about what the data actually shows, because this is where a lot of online claims tend to run ahead of the evidence. Photogrammetric surveys of the interior corners on surviving H-blocks do show measurements holding true to within a few millimeters across spans approaching a meter in length. On some of the best-preserved joint faces, survey data has recorded tolerances down to a fraction of a millimeter. Numbers that genuinely rival the standards used in some areas of modern industrial machining. That's an extraordinary achievement for hand tools and stone hammers, and it deserves to be treated as one, without exaggeration. But it's also true that this precision isn't uniform across every single block. Many surviving joints show looser fits, the result of centuries of erosion, seismic shaking, and the physical damage caused by 19th-century quarrying. Because none of the roughly 150 original blocks remain in their original position, there's no way to recover a true site-wide average tolerance. The honest, scan-back summary is this. Some joints reach sub-millimeter precision, many others do not, and the overall pattern points to a culture with a standardized measurement system and serious quality control, rather than a monument where literally every stone was cut to laser-like perfection. That distinction matters, because it's also the point where this story usually gets hijacked by more sensational claims. You've probably seen videos or articles suggesting that these blocks were somehow poured or cast, like concrete, using a lost geopolymer technology, rather than carved from solid rock. That idea traces back mainly to the work of a chemist named Joseph Davidovits, founder of the Geopolymer Institute, who has argued for decades that some ancient stoneworks, including certain Egyptian and Andean structures, were cast rather than carved. It's important to be straightforward about where that hypothesis actually stands. 2 papers advancing this idea for Puma Punku's andesite blocks were published around 2019, but the casting hypothesis for these specific H-blocks has not been accepted by mainstream archaeology or geology. The petrographic and compositional evidence gathered through the newer scanning and material studies continues to support a natural, quarried stone that was mechanically shaped, not a synthetic, poured material. Independent replication of the more dramatic organic binder claims hasn't been published in a way that satisfies the broader scientific community, and extraordinary claims like this genuinely do need that kind of independent, peer-reviewed confirmation before they can be treated as established fact. So while it makes for a dramatic headline, ancient concrete is, at this point, a minority hypothesis, not a settled scientific conclusion, and responsible reporting on this site should treat it that way. What the new scans do support strongly is a story that's arguably more interesting than a lost technology myth, a culture with organizational sophistication most people don't give it credit for. To cut interlocking, three-dimensional joints across dozens of separate blocks and have them still fit together centuries later, the builders needed some kind of standardized measurement system, a shared design plan, and a workforce capable of executing that plan consistently across an entire platform. That's not the work of isolated craftsmen improvising as they went. It's the signature of coordinated, large-scale engineering, the kind you'd expect from a state-level society investing serious resources into a monumental ceremonial center. The interlocking, notches and lugs cut into the H-blocks, confirmed by both the physical UC Berkeley reconstruction and the newer digital models, also suggest a practical, structural purpose. These weren't just decorative shapes. They were part of a system that let the platform flex slightly and redistribute weight during the frequent seismic activity common to this part of the Andes, a design choice that helps explain why so much of Puma Punku survived a millennium of earthquakes, even though it couldn't survive 19th century dynamite. There's also a broader excavation story happening right alongside the scanning work. In the years leading up to this research, archaeologists working in the wider Tijuana region have continued to report new finds, including additional ceremonial architecture uncovered nearby. A reminder that this landscape is still actively being investigated and that our picture of the culture that built Puma Punku keeps getting more detailed, not less. Every new excavation season adds context that helps researchers interpret what the scanned blocks are actually telling us, tying the H-blocks back into a much larger, still unfolding ceremonial complex, rather than treating them as an isolated curiosity. So where does that leave the central question? How were Puma Punku's H-blocks actually made? Based on the current body of evidence, the most well-supported answer looks like this. Skilled workers quarried andesite from sources a measurable distance away, then transported those multi-ton blocks to the site using human labor and likely animal assistance, an engineering challenge in its own right at this altitude. Once on site, the blocks were shaped using stone hammers for rough work and harder stone or metal tools for fine detailing, following a standardized template that let different blocks interlock precisely, evidenced by the repeated notch and lug patterns confirmed in both the physical and digital reconstructions. Interior surfaces were likely refined using an abrasive slurry, gradually polishing joints down to the remarkable smoothness we still see in the best-preserved examples today. And the resulting structure was engineered with seismic resilience in mind, using interlocking geometry to distribute stress rather than relying on brute mass alone, which is a big part of why any of this survived long enough for us to study it at all. None of that requires lost technology, extraterrestrial help, or a synthetic casting process nobody has been able to independently verify. It requires exactly what the region's archaeological record already shows: a sophisticated, organized society that took monumental architecture extremely seriously. That doesn't mean every question is settled. There are still real, open debates in the field. Researchers continue to refine exactly how much of the tightest, most famous joint precision was achieved through original construction versus how much of it we're seeing, because only the best-preserved fragments survive to be measured at all. Full structural load and seismic simulations based on the digital twin data are still ongoing, and there's more work to be done tying specific tool mark patterns to specific stages of construction. Science doesn't wrap up in a single announcement, and Puma Punku is a good example of why that patience matters. What has changed? Thanks to the 3D scanning work, is that we've moved from a debate based mostly on eyeballing stones and repeating old legends to a debate grounded in millimeter-accurate data that can actually be tested, checked, and argued over using shared evidence. There's something almost more humbling in that conclusion than in any myth about lost civilizations. 1,000+ years ago, a community working at nearly 4,000 meters of elevation, using stone hammers, basic metal tools, and what appeared